in the mathematics. Okay, we have a question paper here, which is the 2019 question paper. Okay, so let's try to answer some of the questions from the 2019 internal. Okay, so we have there section B. Then we have the first question, which is B1 there. Okay, so before we even go to answering that question there, I would like to ask you to invite more of your friends. I know you may have known some of your friends who are in grade 10, some of your friends who are in grade 11, and some of your friends that are in grade 12. Also, some of your friends or relatives that are in those grades, and maybe they may be rewriting their GC exams next year. You can still invite them here on my on my TikTok, so they can just follow me. My TikTok username, which is Katenda or without leaving a space. Then on YouTube they can still follow me, that is Katenda 94277, Katenda 94277, without leaving a space. Okay, so let's go straight to answering the questions that are part of the questions which are in this paper. Okay, we go with the first question first. Okay, so B1, which is section B, question 1. The question reads, matter is made up of 3 basic units. Okay, matter is made up of 3 basic units. State the 3 basic units. Okay, before I go straight to giving answers to this question, there is basic units, and then there is also states of matter. This is where most pupils interchange the answers there. Okay, so when they say basic unit, that is the key word, basic unit. So when they say basic unit, then they are referring to molecules, atoms, and ions. And then there are times when they can say states of matter. So like the question here is saying 3 basic units of matter. The other question may say the 3 states of matter. So 3 states of matter and the basic units of matter, they are 2 different things. Okay, so states of matter, we have solids, liquid, and gas. But when they say basic units, so the keyword here is basic units. So the basic unit of matter, then they are referring to atoms, molecules, and ions. So the question now here says, state the 3 basic units of matter. So we have atoms, ions, and the molecules. So that is section B. So we are saying section B. So which is B1. So B1A, where we have been asked to state the 3 basic units of matter. So the 3 basic units of matter, we have 1, atoms. The next, it is molecules. And the third one, which is ions. So these are the 3 basic units of matter: atoms, molecules, ions. We move on to the next question, which is B. Okay, so which is B. Give the basic unit of matter contained in common salt. So we have to know this common salt. What is this common salt? Okay, so when they say common salt, it is sodium chloride. Now, there you need to think, you need to bring in a lot of things in order to answer that question. So we are saying Common salt, it is sodium chloride. That is in chemistry. When they say common salt, then they are talking about sodium chloride. So, in order to answer this question, we need to know the formula for sodium chloride and how that formula is formed. Which basic units are used to form that formula. So we are saying the common salt, it is sodium chloride, which is that is the formula there, which is NaCl. Sorry, my camera has become okay. Which is NaCl. That is the chemical formula. And now, how is this chemical formula for the common salt? How is it formed? Okay, so this formula, it is formed by the type of bonding, which is ionic bonding. So we are using the word ionic bonding, meaning the ions of sodium and the ion of chlorine combine to form the chloride ions, and sodium ions, they combine to form sodium chloride, meaning the basic unit of matter found in this common salt, which is sodium chloride, it is ions. So we go for B. B, we are saying ions. Okay, or ion. Okay, so that is it. Then let's move on to C. Noble gases like argon are made up of one of the basic unit particles. State the basic unit particle in noble gases. Okay, so when discussing the periodic table, we say noble gases, they are monoatomic. Noble gases, they are monoatomic. They are not like halogens, or let me say group 7 elements, which we say they are diatomic. But we say noble gases, which is group 8 elements, they are monoatomic, meaning they only contain one atom there. Okay, so the basic unit in them should therefore be atom, because we know that we have 3 basic units of atoms, that is molecules, 3 basic units of matter, that is molecules, atoms, and ions. So these noble gases, like the ones they are saying like argon, they are made up of one of the particles. State the basic unit particle in noble gases. So the basic unit particle in noble gases, it is atoms. So atoms, that is C. Okay, we move on. So that means we are done with the first question. We go to B2. Okay, B2A reads, the table below shows the description of substances A, B, and C. Okay, 1, which is A1. Give the physical state of each of the following. Give the physical state of each of them. So we give the physical state of A. We also give the physical state of B and C. Okay, now here we have the description. So meaning A substance A, substance B, and substance C, they are described. So they are described. So now, after they are described, then we are asked to give their physical state of each of them. So the physical state here, they are asking about the states of matter. Like you have seen here, they have even said state of matter. Okay, so let's see. A, they are saying in A, substance A, particles occupy any space available. Okay, then in B, they are saying particles closely packed. Okay, then in C, they are saying particles move randomly with the space of the within the space of the substance. Okay, Then we identify them to be solid, liquid, and gas. Those are the three states of matter that we have. Okay, let's start identifying them. So A, they are saying particles occupy any space available. Okay, so the particle that can occupy any space, any given space, any container which is available, that particle that can occupy that space, any space, it is a gas. So meaning here, which is so this is A1. Then we have 1, 2, 3. So A1 there. So we are saying question 2, which is A1. So A1, we are saying it is here, the states of matter here, we are saying it is gas. It is a gas which can occupy any space available. So we are saying gas. Okay, then we move on to 2, which is B. So it is A2. So this one, they are saying it is A. So we are saying A is equal to gas. Then B, maybe we write it in that way. Okay, so B, let's go to B, the particle B. So particle B, they are saying particles closely packed. So a particle, a substance where particles are closely packed, it is a solid. So in solids, particles are closely packed. That's what we say under the states of matter. So meaning B is solid. Then C, particles move randomly within the space of the substance. Okay, so here usually pupils confuse this one and A. Where they say particles occupy any space available, then they will put liquid here and put gas there. Okay, yes, of course, the molecules in gas, they also move randomly within the space of the substance. But the liquids, they do not occupy any space available. So no wonder A was qualifying to be the gas. So the liquids, they don't occupy any space available. The only substance that occupies any space available, it is gas. So particles move randomly within the space of the substance, then it is liquid. So if it is in the container, they will just move randomly within that space of a container. But we are not saying they will occupy any space available. No, they will just be moving randomly within the space of a container or within the space of a substance. So C, it is liquid. Okay, we move on. Let's go to 2 now. 2. How can substance C attain the structure of substance A? So how can substance C attain the structure of substance A? So substance A, we have said it is gas. And then substance C, it is liquid. So they are saying, how can liquid, which is C, attain the structure of substance A, which is gas? So how can liquid attain the structure of a gas? That is how we can simplify this question. How can liquid attain the structure of a gas? So for the liquid to attain the structure of the gas, then we need to evaporate. So it's by evaporation. So 2, we are saying by evaporation. Okay, So that is the change of state there now from, it is more like the change of state from liquid to gas, which is evaporation. Okay, B. So all these answers we have given, they are for A. Then we go to B. Okay, B reads, substance B is said to be a pure substance. Substance B is said to be a pure substance. Give a characteristic which proves that B is a pure substance when melting. So which characteristic proves that B is a pure substance? Okay, let's see B. So B, we said it is solid. So which characteristic proves that B is a pure substance when melting? Okay, so B melts at the fixed or sharp melting point. It melts at the fixed or sharp melting point. So we say B, or we can just say melts. So we can say B melts at the fixed or sharp melting point. Okay. Then we move on. So B melts at the fixed or sharp melting point. So at the fixed melting point or sharp melting point. And that is the end of question 2. We move on to question 3. Okay. Question 3 reads, the diagram below shows atoms of sodium and chlorine. Atoms of sodium and chlorine. Okay, so those are the diagrams there. Okay, these are the atoms with their electrons. Okay, state, that is A, state the type of bond that exists in the compound formed when the two elements combine. So to identify the type of bond, we need to know the elements there, or the atoms which we have been given. We need to identify them, whether they are both metals or they are both non-metals, or one is a metal, the other one is a non-metal. So here, as we can see, sodium, we know sodium, which is Na. The sodium there, it is a metal. And then chlorine, we know it is a non-metal. So the type of bonding which exists between metals and the type of bonding which exists in metals and non-metals, it is ionic bonding. So they are saying state the type of bond that exists in the compound formed when the two elements combine. So that is when sodium and chlorine combine. Then the type of bonding will be ionic bonding, because it is the bonding for metals and non-metals, or it's the bonding which exists between metals and non-metals. So that is in question 3. So question 3A, we are saying ionic bonding. Ionic bonding. Okay, so we are saying question 3, it's not B, so 3. So question 3A, we are saying ionic bonding. Okay, we move on to B1. Draw the structure of the compound formed when sodium and chlorine combine. So draw the structure of the compound formed when sodium and chlorine combine. Okay, so there we have sodium, the sodium there, which is a metal, and a non-metal, which is chlorine. So In order for sodium to be stable, which is a metal, it needs to lose its one electron in the outermost shell, loses to chlorine. So the chlorine will gain that one electron in order to attain the stable electron structure, which is 8 electrons in the outermost shell. Okay, so here we have 1, 2, 3, 4, 5, 6, 7. So plus the one that will come from there, then chlorine will attain the 8 electron structure, which is in the outermost shell there. Okay, so now here we have been asked to draw the structure of the compound formed when sodium and chlorine combine. So that's the structure that will be formed there. Okay, so we know sodium is like this. So we have sodium. Let's draw it here. Sodium, the first shell, 2 electrons. The next shell, 8 electrons. The last shell, which is 1 electron. And now, chlorine, this side we have the symbol there. We have the first 2 shells, the next 8, and then the last shell, 7 electrons. So 2, 4, 6, 7. So in order for this one to obtain 8 electrons in the outermost shell, it will get 1 from sodium there. So it means this plus this, then this one will lose its 1 electron, and its 1 electron will go there. So when this 1 electron goes there, then what we obtain is what the question was asking for. So meaning sodium now will be like this. Okay, so the first shell for sodium, 2 electrons. The next shell, 2, 4, 6, 8. Meaning the last shell there has been lost. The electron there in the last shell has been lost. So we only remain with 2 shells like that, with the last shell having 8 electrons, which is 2, 4, 6, 8, which is the stable electron structure. Okay, then we have said this sodium has lost 1 electron, so we can put it in brackets like that, box brackets, and then it will form a charge there. So when a metal is when an atom has lost electrons, it forms a positive charge. Now it has lost 1 electron, so the charge will just be positive. If it had lost 2 electrons, the charge was going to be 2 positive. Okay, then we also draw for chlorine, which has gained. So here we draw it. The first shell for chlorine, we know it's 2 electrons. We are just duplicating what is there on top. The next shell, 8 electrons, so 2, 4, 6, 8, and then the last shell will have 2, 4, 6, 7, and then plus the electron which has been lost from sodium, which will be here. We even show with the cross there to show that it has come from sodium there. Okay, we also put this in brackets, and then it has gained how many electrons? 1. So when an atom has gained an electron or electrons, it gets a negative charge. Now that it has gained only 1 electron, so the charge is just negative. Suppose it gained 2 electrons, then the charge was going to be 2 negative. Okay, so this is what the question was requesting us to do. So this is the answer there. Those are the structures that were required for us to draw for this question. Okay, we move on to B2. So that was B1. Okay, so this was B1. So B1, which is B1, the owner of this answer there. Okay, next. So we have a few minutes on our time there. Okay, so the next question, which is B2, state the chemical formula for sodium chloride. Okay, so that is simple. Sodium chloride, the chemical formula for sodium chloride. Okay, so it is simple. That is B2. State the chemical formula of sodium chloride, B2. So 2 here. Okay, so sodium, we know is this, and then sodium, we know it is Na, and then chlorine. Sodium has the valence of 1 because it loses 1 electron and it is in group 1. Okay, so also chlorine, the symbol is like that. Chlorine has the valence of 1 because it gains 1 electron for it to be stable. Okay, so when these valences they interchange, they will still get sodium 1, chlorine 1. We don't even need to write the ones there, they are invisible, unless if it was a 2, we are going to write a 2 there. So that is the chemical formula for sodium chloride. Okay, so when writing chemical formulas, you need to know the valences of atoms or elements which have been given to you. So like sodium, they have said sodium chloride there. So state the chemical formula for sodium chloride. So you need to know the valence of sodium. You also need to know the valence of chlorine there. Okay, so that's the chemical formula there. Let's move on. We move on to C. Okay, so C, explain in terms of bonding and structure why sodium chloride has the following properties. A very high melting point. So why does sodium chloride have a very high melting point? Okay, so that is the C1. C1. Okay, C1. Okay, let's get to the question. So we explain in terms of bonding and structure why sodium chloride has the following properties. A very high melting point. Okay, so sodium chloride has the very high melting point because of the strong forces of attraction that hold the negative charged and positive charged ions there. Because of the strong electrostatic forces of attraction that hold the negative and the positive ions there, which is the positive ions and the negative ions. So we are saying it has the very high melting point because of the strong electrostatic forces of attraction that hold